All right, welcome to the brief calculations discussion for Lab 6. This is all Chapter 6 material, so hopefully it sounds familiar and isn't too arduous. Mostly, I think it'll just be helpful to talk about a few things that sometimes people forget to do with this lab, and that'll just make the process easier as you try to do things. Okay, so first and foremost, for all of these calculations, you're going to use equation 2, which I have written out here, and the C of the calorimeter. It's that 15. It's that experimentally determined number. Okay, so most of your calculations involve figuring out delta H for the reaction for both reactions 1 and reactions 2. Reaction 1 is when you mixed HCl and sodium hydroxide. Reaction 2 is number 2 here, and it's when you mixed HCl and that magnesium ribbon. So let's talk about reaction 1. You're going to use equation 2. Some things to watch out for are this. The mass of the solution has to include the mass of both the HCl and the sodium hydroxide solutions that you used. In other words, you're going to figure out the mass of each, you're going to add them together, that's mass of the solution. To get your mass of the solution, you want to take into account that the density is given for each, right? So for HCl, you want to use a density of 1.05 with whatever volume you used. For sodium hydroxide, you want to use 1.11. The other thing is C of the solution. You don't want to use the C for water. You want to use the one that's given, 3.94. The calorimeter, big C, is that 15. And then the temperatures are what you got from the experiment, your initial and your final, right? That'll give you your change. Once you have the answer for A, once you have the Q for the reaction, you want to divide that by the moles of reactant to get a Q in terms of kilojoules per mole. The molar amount that you want to divide by is based on the limiting reagent. So depending on whether HCl or sodium hydroxide is limiting, whatever is limiting is the one you're going to divide into your answer for A. A little typo here that I noticed, you want to use your volumes, how much HCl and NaOH you used, and the molarity of each solution. That's how you want to calculate the limiting reagent. Don't use the density. All right, number 2 here is the same sort of thing. You're going to use equation 2 to get Q for the reaction. For A, when you're solving for Q, you want to make sure that you get the mass of the solution. The mass of the solution here is going to involve both the HCl and the magnesium. So however many grams or milligrams of magnesium you used, you want to add that to the mass of HCl that you used. In this case, the 1 molar HCl has a density of 1.01. You want to use the volume of HCl you used and that 1.01 to get your total mass. The specific heat of the solution is 4.04. You got more water in there, and so it's a little higher than it is for reaction 1. Once you get this Q, you're going to divide it by the moles of magnesium to solve the reaction in terms of, or to solve for delta H in terms of kilojoules per mole. And then you can move on to 3, which is verifying Hess's law. This is, all you're doing here is taking reaction 1 and 2 and their associated delta H's, summing them up so that you can get a net reaction 3 and solve for delta H of reaction 3. The hint that I want to give you is to write out equations or reactions 1 and 2 in terms of their net ionic equation. Once you do that, then you can rearrange both those reactions to get to reaction 3. And that's pretty much it for the calculation section. The other sections are like the discussion and error and the conclusion. Make sure to address each part of those sections. For this lab, there's a rubric If you just address the parts of the rubric, you will be fine. And thank you for listening to this. If you have any questions, we'll have time to talk about it on Thursday. If not, you can always email me. This lab will be due a week or so from today. All right, thanks, and I will see you on Thursday.